Welcome to Super Easy Physics and Mathematics, SEPAM. Today we are looking at the question that proved quite challenging for the student that wrote the May-June Physics Paper 2 Extended 2021. So in this particular Paper 2, we are looking at the question that most candidates failed, the candidate that wrote this exam. So as we are preparing, we are going to discuss the technicality and then the misconception why most students fail this question. So this is just a smart way of preparing for your exam. So let's go into this and look at some of the questions that most candidates fail so that you don't need to fail them if you come across them. Now, a ball falls with different mass. 4 balls with different mass are dropped from the height shown. So we have the ball A dropped from the height of 1 meter, then ball B is dropped from 2 meter, the height of 2 meter, C is dropped from the height of 3 meter, and D is dropped from the height of 4 meter. And each of them have different masses. Air resistance may be ignored. Which ball has the smallest average velocity? So that is the question. Which ball have the smallest average velocity? Now let's look at why most students failed it. Most students pick option D, possibly based on it being the lightest of the ball. So most students assume that the ball that is the lightest is going to travel with the slowest speed, but that is not correct. So this option is wrong. Now what we are going to look at here is that the principle behind this question is the conversion of kinetic energy from gravitational potential energy that the ball has before it was dropped, and then the gravitational once the ball is released, the ball starts moving, and then the gravitational potential energy is converted to kinetic energy. So if you analyze that, you cannot find the speed with which the ball drops, which is going to be the square root of 2gh. So if you apply that to each of these questions, so you see that the mass does not affect the speed. So 4 kg, 3 kg, 2 kg, and 1 kg, if we drop them from the same height, all of them are going to fall with the same speed. So the mass does not have anything to do with it. So the issue of the lightest ball is not a consideration. So what affects the speed is the strength of gravity and the height from which the ball is dropped. So the one that is going to have the smallest average speed is the one that is dropped from the shortest height. So that is why A. So if you look at it, if we calculate that, the 4 kg ball dropped from the height of 1 meter fall with the average speed of 4.5 meter per second, while the 1 kg dropped from 4 meter fall with the average speed of 9.8, which is almost 9 meter per second. So the ball D actually fall with the highest speed. So the speed gradually increase from A to D. So the one that form with the lowest is going to be A. So A is the correct answer to this question. Question 7. A cat has a mass of 10 kg. A boy pushes the cat horizontally with a force of 50 Newton. The cat accelerates with this at the rate of half meter per second square. What is the frictional force acting on the cat? So let's look at this. Now many students pick option A. So that is 5 Newton. Now probably by multiplying the mass by the acceleration. So what they did, they just multiply this mass, which is 10 multiplied by half will give you 5 Newton, but that is a wrong mathematical on this question. The concept is wrong, so A is wrong. So let's see, so that you don't make the same mistake. Let's analyze. So if you look at the net force, so the ball is being pulled with the force of 50 Newton. So let's assume it's pulled to the right. Then frictional force we add to the left. So if you have that, so we are looking for what is the frictional force acting on the object. So if you do the horizontal, so the net force is going to give you equal to the mass multiplied by the acceleration. So if you do that, 50 take away the frictional force will give you the net force, which is the mass multiplied by the acceleration. So solving this equation gives the frictional force of 45 Newton. So the correct answer is D. Let's go to the next question. Question 8. A ball has a mass of 2 kg. The ball approached a wall at the speed of 3 meters per second and rebounds at the speed of 1 meter per second. So he's coming this way. So if you look at this, this is a question that has to do with impulse and momentum, collision. So what is the impulse on the wall? Now, many students pick option B, which is this. Now, without considering the vector aspect of the velocity, and take note, this question, examiner always like testing students on this question that has to do with collision, momentum. So take note of it. So you have to realize that velocity is a vector quantity. So when it's facing west, if you take this west direction as positive, then the direction going east, the rebound is going to be negative. So let's find the impulse. So what is the impulse? Impulse is going to be the initial momentum, take away the final momentum. So if you take direction going to the west, the initial direction of the velocity as positive, then the final velocity will be negative. So put that. If you do the calculation, it will become 8 Newton second. And take note, the examiner also, they are testing the unit of impulse. So the A was in Newton, B was Newton second, C was 8 Newton, and D was 8 Newton second. So the option is between B and A. The unit of impulse is not force, so that automatically eliminates A and C. So the answer is between B and D. So the correct answer based on our calculation is D. Let's go to the next question. Question 10. A student suggests that there are several ways of transferring energy to a small stationary block of iron on a smooth table. He makes the following suggestion. Okay. Supply thermal energy to it, shine light on it, pass a current through it. Which suggestions are correct? Wow. So, transfer thermal energy, then pass electrical energy. Well, most students, they really have problem with this. So they feel many candidates pick option B, which is what? 1 and 3. But they didn't actually recognize that shining light on the object will involve transferring heat to it. So the actual answer is what? All of them involve transfer of heat, because in suggestion 1, thermal energy is transferred, 2, solar energy is transferred, then 3, electrical energy is transferred. So the actual answer is D. Question 11. An engine produces 240 kilojoules of energy in 20 minutes. What is the power output of the engine? Now let's see, many students pick option B. Now what is the possible reason? You know what they did? Think they just divided the energy produced, because power is equal to energy produced divided by time taken. So they didn't convert these 2 minutes into SI units. So if you divide 240 kilojoule by 2, it will give you 120 kilowatts. So that is why most students fail that question. They did not convert the 2 minutes to seconds. So let's do that. Let's do the conversion. So if you convert it to seconds, so 2 minutes is the same to, instead of dividing by 2, you are going to divide by 120 seconds, which gives 2000 joule per second, which is the same thing as 2 kilowatts. So the actual answer is A. Let's look at the next question. Now, question 12 has to do with another question that has to do with units. A book has a mass of 400 grams. Take note, 400 grams. I put it in highlight, and this was the trap in this question. The surface of the book is in contact with a table which has a dimension of 0.1 meter multiplied by 0.2 meter. The gravitational field strength in that location is what? 10 Newton per kg. What is the pressure exerted on the table due to the book? Now, what do you think most students? Many students fail this question 12. Let's look at the possible reason. They did not convert the unit properly, and most of them did not know the formula of pressure and how to, translate. So most of them that got the formula, they don't know how to translate it. So let's see. So pressure is equal to weight divided by the base area. So the milligram, so you have to convert that 400 gram to kilogram. So in red, so look at that. So that gives the pressure of 200 Newton per meter square. So the correct answer is D. Let's go to the next question. Question 13. The diagram shows a mercury barometer. At which point is the pressure greater than atmospheric pressure? So if you look at this, now let's see why many students fail this question, because they thought that the pressure in the torricellian vacuum is not above atmospheric pressure. So if it's not above atmospheric pressure, so most of them was going to pick option C. So, but what you should know here, that the pressure is going to be, when you say which one's point is have the greater pressure, so which point is the pressure greater than atmospheric pressure? So if you look at it, so the pressure due to the mercury, which is the density multiplied by strength of gravity multiplied by the height. So once you know this height here, the distance between C and the midway between A. So once you know this height, multiplied by the density of mercury and the strength of gravity, then plus atmospheric pressure. So the distance there is going to be, the point is going to be D. That's where you have the highest pressure. Let's go to the next question. Wow, this question appears simple, but most students don't actually understand the molecular explanation of conduction. So many students fail this question. They did not recognize that atomic vibration transfer energy to the free electron and receive it at the destination. So when you hit the end of this rod, X, then what's going to happen? The thermal energy that is supplied is going to make the atom at S to vibrate more stronger, and then as the vibration increases, the distance between the particle, the lightest vibration, increases. So as they move, they transfer energy, and then with the free electron move here across from position X to Y, and so they move the energy along. So A is the correct one. Energy is transferred from end S of the rod to Y by vibration of positive ion, that is the atom, and by movement of electron. So that is the option that is correct. So the two major things responsible for conduction is what? Vibration of positive ion and movement of free electrons. So take note, that's how to underline them. So take note of these two process, the red and then the blue. Question 20. The two square sheets P and Q are heated at the same temperature. The metal sheets are shown, that is P and Q. So P is 20 cm wide, while Q is 40 cm wide. Now, take note of this. The sheet Q is emitting more radiation than sheet P. So take note. Sheet Q is emitting more radiation than sheet P. So this answer, on this question, so take note, you have to underline this statement here given to you. Which statement explains this? Now, many students pick option A. Dull black surface are better conductor of radiation. Correct. That is a correct something, but without this condition given here. So now, because candidate recognize that black surfaces are better emitter than white surfaces, but there is a special condition in this question underlined in blue. So that is a special condition. So most students did not read this question properly, and look at the condition given. So on the basis of this condition, so what is responsible why Q is going to emit more radiation than P? A white surface emits more radiation, thermal energy, than this black surface. Okay, the reason is that this white surface has a wider surface area. So the surface area of Q is greater than the surface area of P. So if you look at it, because there are two factors, the nature of the surface and then the wideness of the surface. These are the two things that affect the rate of radiation. All right, let's go to the next question. Question 21. A water wave passes into a region where the wave travels more slowly. So it's moving from high speed region to a slow speed region. As it passes into the slow region, what happened to the frequency and what happened to the wavelength of the wave? So let's look at now. Many students pick A. Frequency decreases and the wavelength remain the same, because they lack the correct understanding of this concept of the behavior of the velocity, wavelength, and the frequency of the wave when wave move from one region to another as it travel. So let me just do a slight explanation. So now, if you have this, let's assume that the water wave is moving from deep region to a shallow region. Now when you say it's passed from into a slow one, so shallow region, so you see I'm deliberate. This lemon color you see that the depth of the water is lower, while this blue here, the depth of the water is higher. So you have deep water, then here you have shallow water. Now in deep water, water waves travel faster, so you have a higher velocity, while in shallow water it has a slower speed. Now take note, so how do you do that? The wavelength, fast speed wavelength is higher than in deep water. Then if you come into the shallow water, the wavelength is shorter. So look at the gap between the waveform front. Then if you look at here, the gap here is closer, so that's to tell you that it has shorter wavelength. Then, so what happened from this one? Wavelength decreases. So now we have fast speed, the speed decreases, wavelength decreases. So the remaining factor is the frequency. So what happened? In both cases, the frequency remain constant. So the frequency of the water wave in deep water and the shallow water remain the same. So we have to take note of that. So what is the correct answer? The correct answer is C. Frequency remain constant and the wavelength decreases. So I hope this will help you to understand it next time. Let's go to the next question. Question 23. The diagram shows a narrow beam of light incident on a glass air boundary. Some of the light emerges along the surface of the glass and some is reflected back into the glass. Which rule is correct? Now this is an example of total internal reflection. Then the angle theta is the critical angle. So we are actually, the question is analyzing now what is the value of this angle? Is it the critical angle? Is it less than the critical angle? Or the total internal reflection take place based on this diagram? So well, let's see. Most students fail this question because our total internal reflection, these are the two conditions for total internal reflection. The angle of incident theta must be greater than the critical angle for total internal reflection to take place. Then there is no refracted ray when total internal reflection takes place. Now at total internal reflection, the ray at the angle, the critical angle, so if you look at it, this diagram, at critical angle, the ray is refracted along the boundary between the glass and the air. So in this case, if total internal reflection takes place, this component will not be there. The ray, everything will be reflected back into the glass. So that means the condition, take note of that condition. Some of the light emerges along the glass air interface. So that means total internal reflection did not occur. And then the angle theta is the critical angle because it emerges along the interface between the glass and air. So the angle of refraction here is 90 degrees. So from this point, so the angle of refraction is 90 degrees. Question 32. The diagram shows a light dependent resistor in a potential divider. A voltmeter is connected across the LDR. Which row shows the resistance of the LDR and the potential difference shown on the voltmeter at the specific light level? So if you look at this, I think many candidates fail this question because the resistance of the light dependent resistor is low in bright light, and then the potential difference across it is low. So once the resistance reduces, then PD also reduces. And if resistance increases in dark light, then the PD also increases in dark light. So so most students don't understand the operation of light dependent resistor. So let's do a little. So light dependent resistor in bright light. So you see that the resistance decreases in bright light. So in bright light, resistance decreases. If resistance decreases, what is going to happen to current? Current increases. So what is the correct answer? If current decreases, what is going to happen? So in dim light, you're going to have high resistance and high PD. So I've already explained that here. Wow. I know you're a brilliant student. You are looking for a way to ace this exam. I want you to subscribe to this channel because more tutorial solving past exam questions that will give you clue, that will give you some trick and tips for you to be able to have a better performance in your exam will be uploaded. So please kindly like, comment on the video, share it with your friends, and if you have any question, just write your question on the comment section. I'll take out time to reply you.